Hello students, today we are going to discuss one of the another interesting chapter in the physics, which is known as the electromagnetic induction, and today we will discuss its the part 1. As per our the last discussion, we came to know about the magnetic effect of the current. Whenever something being discovered or invented, suppose by using some process, something is converted to the another thing, or by using some things, we are finding some facts. Then the question will come in the human being that, is it the reverse will be there? So, by thinking the magnetic effect of the current, the process states that if some current will pass through the electric, some current will pass through the conductor, it will produce the magnetic field, and that type of the process is known as the magnetic effect of current, means the magnetic effect due to the flow of the current. Therefore, the question will come here, if there will be some change in the magnetic field, is there any current will produce or not? Then actually it found that due to the change of the magnetic field, there will be the some current. Therefore, the name of this chapter is designed as the electromagnetic induction. Electro means from the electron, magnetic means from the magnet, induction means without touching. So, without touching of the current and the magnetic field, means the conductor and the magnetic field, or the coil with the magnetic field, the some new currents being the developed, and that branch is known as the electromagnetic induction. So, in this electromagnetic induction chapter of the part 1, we are going to discuss today as the magnetic flux, what is the magnetic flux, and the electromagnetic induction process, how it being came to the human being. The Faraday's observations means regarding the electromagnetic induction, some concept which is given by the Faraday, and he has taken some observation that is known as the Faraday's observation. Next the Faraday's laws, then comes the Lenz's law and the motional EMF. These things we will discuss in our class. So, let us first go for the magnetic flux. So, this magnetic flux which is represented by the phi. So, this magnetic flux is resembles like the electric flux, as we know in our the earlier chapter. Electric flux, that being written as the symbol of the E. This electric flux E and this is the magnetic flux. For the magnetic case, we have written it as the phi B, or in some books you will find it is the phi of the M, or generally you can write this is also the phi. So, what is the magnetic flux? Likewise of the electric flux. So, about the electric flux, you know that flux is equals to the phi of the E, this is the phi of the M or the B. Phi E is equals to the E vector dot of the ds vector. So, though the electric field is corresponds for the E, the magnetic field is has its the magnetic induction or the magnetic flux strength, that is the B. Of the this ds is also the area. Suppose you will say here the area is the A. So, therefore, the flux is equals to depends upon the phi and the area of the cross section, or you can some books you will find that is also the A, whatever your choice. So, though this is the EDS, you can write this is the B of the D. If you will write this is the ES, then you will write this is of the BA. But how this BA being the developed, that we will go for the observation. Suppose we have a conductor. this is your the B. So, though this is the magnetic field, as we know earlier, every magnetic field must have its the magnetic field lines. So, if these are the magnetic field lines and this is your the conductor of your the certain area, then you will find that here this B and your this number of the field lines are passing through this area as the number of your the 2. So, the magnetic flux it is defined as the number of magnetic field lines passing perpendicular to the surface. Perpendicular to the surface. Very important term is your the perpendicular to the surface. So, if this is your the surface and this is your the magnetic field lines, so how many magnetic field lines are passing through it perpendicularly? So, here the number is your the 2. So, if this is the 1, this is the 2. So, here the number of your the magnetic field lines passing, that is equals to the 2, means here the phi means the magnetic flux is the number of, that is your the number of magnetic field lines. Here the magnetic field lines is the 2, so phi is equals to the 2. This is your the first observation. Now, if we will increase the magnetic field strength, magnetic field strength means the same flux being here the same area being here the taken, but here this is your the B, and for here the number of the magnetic field lines that is passing here the number is the 4. You see there are the 4, 1, 2, 3, 4. So, phi is equals to your the 4 here. So, the third observation is, this is your the first case we have taken, this is the second. So, in the second what we made? We just increase the magnetic field lines, means if this magnetic field lines we have taken, that is equals to your the B, and in the next case suppose we increase, that means here the 2t, means twice we have taken or the thrice, whatever it may be. So, if it is the increase, then the number of the lines passing through perpendicularly, that is your the 4. And your the third one is your the, suppose the area being your the increased. Now, in these two cases, the magnetic field strength being your the increased, and here the area being your the increased. So, how many lines are passing through this area perpendicularly? 1, 2, 3, 4, 5, 6, 7, 8. Means there are the 8 lines are passing through it here the perpendicularly. So, here the phi is equals to here the 8. So, this shows that the magnetic flux phi on increasing the field strength, it is your the related with your the increases by increasing the field strength, and also it increases by increasing the area, means by increasing your the area. So, it observed that the magnetic field lines will be the more when the magnetic field strength will increase and the area being your the increase. The next question comes, suppose these magnetic lines are not passing your the perpendicularly, means if this is your the area and the magnetic lines to be your the pass through it is your the perpendicularly. Suppose in any case that will not pass through your the perpendicularly, means the next case is your the fourth case. The conductor we have taken, this is must be it's the area 1, means that is it's the B vector we have taken, and this is your the magnetic lines, and this is your the area, means here the area vector, and this is your the B. So, with this perpendicularly, it is making your the angle of your the theta. So, you see here the B is just passing through the perpendicular to this one, but here it is making here the certain angle. So, if it is making the certain angle means, suppose this is your the surface one, and here the magnetic fields are passing likewise, means your butter on your the bread, like the butter on the bread, so when we are adding that one, in that process it is your the passing. So, what it will be, and now this B will have its the two components. So, this is one component, this one component will be your the B cos theta, this component will be the B sin theta as per our the earlier discussion. So, this B cos theta means it is going here the perpendicularly, but this B sin theta, it is not passing through the perpendicularly, means it is going in this way. So, it has its the no effect, but only the effect will provide here the B cos theta. Therefore, instead of taking here the B, here it will be here the B cos theta. Therefore, the phi is equals to here the A of here the B cos theta, and if it is A of the B cos theta, means this is your the B vector dot of your the A vector, that is your the phi. So, the magnetic flux takes the importance role for the invention of the electromagnetic induction. Means you see this B is equals to this phi is equals to the B vector dot of the A vector. This is the dot product of the two vector. So, dot product of the two vector is always the scalar. So, the magnetic flux, as you know earlier, the electric flux, that is also the scalar quantity. So, magnetic flux is the scalar quantity. What will be the unit? The unit depends upon the B and the A. B is the magnetic induction, as we know, if it is in the Tesla, then A will be your the meter square, then Tesla into meter square will be your the Weber, and for your the CHSE you will have this is equals to your the Gauss, that means here that is the EMU, and this is the centimeter square, and that is equals to your the Weber and your the Maxwell. So, there is a relation between that two. So, by taking this magnetic flux into your the concept into the account, we the Faraday has observed that how this magnetic flux will make your the electromagnetic induction. Suppose you are the B. So, B to B are the varies. B to B are the varies, and we have taken a conductor. Suppose we have taken a conductor. When the B to B are the vary, it observed that through that conductor some current to be the induced. Induced means actually it has your the no current, but when this B to be are the vary, then the current to be are the induced here. Here you will find induced current. Means actually we have taken no current, but when this B to B are the vary, then the some current to be are the observed. So, how that current to be are the observed? If we connect it through your the galvanometer, then indicates that there is a deflection. So, this is on varying of your the B. Suppose we increase the area. So, area to be are the increase. Area to be the increase, area for that one to be the increase, and this is your the B. Then also it is obtained that on its the flow you will find there is some induced current. Some induced current. Similarly, the conductor to be or the rotate means making at the certain angle, still you will have that some induced current. Some induced current. So, it shows that the induced current. So, when the current is there, so how the current will arise? Before the EMF or after the EMF? So, if the current is there before that one, there must be some potential difference. some potential difference. But here we are applying no electric field or the no battery being taken. So this potential difference earlier to this one is known as the induced voltage. Induced voltage. So this induced voltage E, it being here the varies by varying here the B. Now it being here the varies by varying here the A and also by varying here the theta. So if we will observe by varying the B and here the A, these B and here the this BA and here the theta, you see earlier we have written phi is equals to here the BA cos theta. Means if B, A and theta to be here the vary, then here the phi to be here the vary. So this phi to be vary means it produces here the flux. So by the existence of the flux, we came to know that there is a existence of here the electromagnetic induction or here the induced EMF is there. As we came to know that when there is a change in your the B, A and your the theta, this B, A and your the theta, they are related with your the phi. So if B, A and theta to be your the changed means your the there is a change in its the phi. So this phi will shows your the induced EMF. This is your the one case. So another case you can also make. Suppose and we are taking a boromagnet, not boromagnet, that is your the bar magnet. So we are taking a bar magnet. So when the bar magnet will be taken, so when this bar magnet being taken, this is your the Faraday's observation. Faraday's observation, second observation he has taken. So when this magnet being here the taken, means this north pole is taken towards it. When the north pole is taken towards it, there is here the number of the field lines to be here the pass through this of your the conductor. Then there is a deflection in your the galvanometer. This. Suppose your the north pole and the south pole polarity to be here the changed. Suppose this south pole will came here and the north pole will taken there. So the south pole means it's the direction will be here the changed, means this will be here the towards. So this will here the this direction and this will here the away. So here the magnetic lines are here the goes away. Suppose you are taking away from it is goes away. When the north pole is taken, it is coming towards. So on both the cases there is a deflection. In one case if the deflection in this direction, in another case the deflection will be it's the reverse. Because the number of the lines of force direction being here the change, therefore here the deflection being changed. So from this experiment he came to know that whenever there is a change of the magnetic field, so change in magnetic field will lead to the change in flux. So this change in flux ultimately produces your the current. So before the current, it must produce your the EMF and then it will give you your the current. So by taking this concept, Faraday has given you the some laws and known as your the Faraday's laws of the electromagnetic induction. So Faraday's laws of electromagnetic induction. So, electromagnetic induction means the without touching. So, when the coil and the magnet being taken, there must be the some gap between them. So, the first law is whenever there is a change in magnetic field, what we obtained? There is induced EMF. If the conductor is closed circuit, the induced current will be there. Induced current will be produced. Whenever there is a change in the magnetic field, there is induced EMF. And the second one is, as long as the induced EMF is there, we have induced current. Induced current. In some books, the first and the second, they are combinedly taken as the one. Means you see, whenever there is a change in magnetic field, there is induced EMF, and here the ends with the induced EMF. As long as the induced EMF is there, there will be the current. So, if we will combine them, suppose all boys are girls and all girls are your the goat, then what will say that? All boys are your the goat. Similarly, the first and the second to be the combined means whenever there is a change in magnetic field, there is a induced EMF. In some books, by taking these two, they have taken as the one, and I have taken it part by part. So, the third one is the magnitude of induced EMF is equal to the rate of change of magnetic flux. Rate of change of magnetic flux means it never depends upon the flux. Kindly go through this. It never depends upon the flux, but it depends upon the rate of change of flux. Suppose this is your the coil and this is your the magnet. If the magnet will taken towards it with this speed and the magnet will taken with the high speed, then what will happen? The rate of change being your the varies, according to which the current to be your the vary. With the same magnet, if we take slowly, with the same magnet, if we take with the fastly, then it is observed that due to your the first one, the rate means the time is your the reduces, therefore its magnitude will be your the more. So, mathematically, but we are writing it mathematically. So, mathematically E is equals to del phi by your the del t mod. This is its the magnitude, and this E will be its the AVG, means it's the average, means during the time interval. If we take instantaneous, then this is equals to your the d phi by your the dt. So, this is its the magnitude of your the induced EMF. So, you see, if this phi to be your the change, means this delta phi, you can write the phi final minus phi initial by your the t final minus t of your the initial. So, likewise, we will find its the magnitude. Therefore, by your the Faraday's law, we came to know that E is equals to your the delta phi by your the delta t or your the d phi by your the dt. Suppose phi is equals to your the 5t square. plus 60 plus 7. This is your the phi. Find induced EMF at time is equals to your second, means 2 second. 2 means not you, 2 second. T is the 2 second. So if this is a problem, so how you will find it is the solution. So the phi is given, the question is find the induced EMF. Induced EMF means E. So we are interested for the E. So E is equals to the d phi by the dt. So the solution will be, we know E is equals to the d phi by the dt. Sir, why you have taken d phi by dt, not you have taken del phi by del t? As I said just 2 minutes earlier, it is calculated to find the value at t is equals to 2 second. 2 second means at that second means it is the instantaneous one. So for the instantaneous, that is the d phi by the dt. But this is its the average one. Average means during the some time interval. Means if the question will come, what will be its the total EMF during your the 5 second. During the 5 second means starting from your the 0 up to your the 5 second. Then you have to take in that del t is equals to the 5. Similarly, you will find it's the delta phi. So E is equals to d phi by dt means d by dt of a phi. Phi is equals to the 5t square plus 60 plus of the 7, that is equals to the 10t plus 6, that is equals to the E. But where we have to find? At your the t is equals to 2. So E at t is equals to 2. So if you put t is equals to 2, 10 into 2, 20, 20 plus 6 is equals to the 26. So induced EMF will be the 26, that is its the value. So by remembering this formula, you can easily find out what will be the magnetic flux. So many other problems are there. So you go through your the books, and if you have your any problem, you can contact. As per our discussion, we came to know that what is the observation given by your the Faraday and the laws given by your the Faraday. According to the Faraday, there are the two laws. The first law is, whenever there is a change in your the magnetic flux, there is a induced current. And the second one is, the magnitude of the induced EMF is proportional to or equals to the rate of change of the magnetic flux. Though it is the induced EMF, then the question is, what will be its the direction? How that induced EMF being your the developed in a conductor, and that was given by your the scientist whose name was your the Lenz, and therefore the direction of the induced EMF is also known as your the Lenz laws direction. So now we will go to discuss the Lenz law. Lenz, L-E-N-Z, Lenz law. So according to Faraday's law of EMI, E is equals to d phi by your the dt. This phi is your the flux due to your the coil. If the coil has your the number of the turns, then this can be written as your the d by dt of your the n of your the phi. And if that n will comes out, then that is your the d phi by your the dt. So next, if the Lenz law is there, how that Lenz law being your the developed and what will be its the direction? Suppose we have a inward magnetic field. This is your the inward magnetic field. In which we have taken a conductor. Inside it there is a conductor. Suppose the B is increased. So when the B to be or the increase, then what will happen according to the Faraday's law? You see, E is equals to d phi by dt, and that can also your the d by dt of phi. Phi is equals to the BA. When the B to be or the increase means, B to be or the increased means the E to be or the increase. E means here the induced EMF to be here the increased. So, when the induced EMF to be increased, then there will be here the some current you will automatically found. If the current will develop, means here induced current will be there. So, what will be the direction? Means though it produces the current, there must be it has its the direction. So, what will be its the direction? Either this way is its the direction or this way will be the direction. That direction was given by your the lens. So, he given a statement. The direction of induced EMF is always, not some ways, is always opposes the cause producing it. The cause producing it, very interesting thing. The direction of induced EMF means if the B is increased here, due to the increase of the B means variation of the B, the E to be the developed. When the E to be the developed means there must be the current. So, that current which is developed due to the increase of the B. So, the statement is that one is always opposes, means the direction of the induced EMF always opposes the cause producing it. Who created that one? Means that induced EMF is opposing to that one. So, what a nature, what is the law of this nature, you just look it. Suppose the sun is produced by your the father. So, when the sun is produced by the father, that sun will oppose to your the work of your the father. That is the way what the lens has said. Suppose instead of the sun, suppose the daughter is produced. So, the daughter who is developed due to your the father, then the daughter will oppose to the work of your the father. That is the statement of your the Faraday's law. Means what actually going here. So, instead of saying here the son and the daughter, suppose you will say that one is the kid. Means this kid kills father. This is your the statement of the Planck's law. Kid kills father. Means if this is your the inward one, means it is your the inward one. Suppose due to this inward magnetic field, due to the increasing of the field, the current which is developed, what that current will do? It will oppose to that one. Means when the B is increased, phi will increase. When phi will increase, means induced EMF. So, induced EMF is there. This induced EMF, what it will do? It will just oppose to that one. Means if it is in your the inward direction, means the direction is in this way. Suppose the current which is developed, suppose you will take the current is in this way, then what will be the direction? Means if you will rotate this one in that direction, and it will your the in this direction, means the direction of the thumb will be the field direction. So, if the current will move in this direction, as I am indicating here, suppose the current will move in this direction means which one? That is your the anti-clockwise direction. So, if the current will develop in the anti-clockwise direction, then it will satisfy your the Lenz law. Suppose you will say that the current is producing in this direction, means in your the clockwise direction. If the current will be produced in the clockwise direction, what will it see? The direction of the magnetic field you see. If the current is moving in this direction clockwise, means the direction of the thumb will be see the field direction. So, the thumb is in your the inward, already the field is in the inward direction. If both are in the same direction, what will happen? The induced field direction to be the increase, means it is not your the opposing that one. So, this is the direction of your the induced EMF. Suppose instead of taking your the inward field, let us have an outward field. we have an outward field. This is the outward field. We have taken a conductor. We have taken a conductor. So, this B is increased. Suppose the magnetic field to be the increased. When the B to be the increase, it will leads to the magnetic flux to increase. So, due to the change of the magnetic flux, what will happen? The induced EMF will be produced. So, it will create induced EMF. Are you clear, my students? This is your the inward field, this is your the outward field. In case of the inward field, suppose the magnetic field strength increase or magnetic field strength is just decrease, whatever it may be. If you increase the magnetic field or decrease the magnetic field, there is a change of the magnetic field. Whenever there is a change of the magnetic field, there will be the induced EMF as per your the Faraday's law. So, if the induced EMF is there, then it must produce your the induced current. Then what will the direction of that current? That was given by your the lens. That thing we are discussed here. Just it is the opposite one. Suppose this is the inward field, we have some your the outward field. Means the field is in this direction. Suppose that field strength we are the increase. Field will increase means the magnetic flux will increase. If the flux will increase means induced EMF will increase. If induced EMF will increase means induced current produced. So, though the induced current being the produced, suppose here some current you will find. How you will come to know that the current is there? Suppose it will connected with the galvanometer, there is a deflection in the galvanometer, so the current is there, we confirm. But what is the direction of that current? So, according to the Lenz law, it will just oppose to that one. Oppose means it is in your the outward direction. So, it to be opposed means if the field which is developed due to the flow of the current through this conductor is also in the same direction, means the resultant field will the increase, means it is not opposing. So, it to be in your the different direction, means if it will be in your the in this direction, suppose we will say it is flowing in this direction, the current developed in this direction. Suppose the current developed in this direction means what will be the field direction, means you have to make your the current, means the current to be the rotate. You have to rotate your the four fingers or the curl the four fingers along the direction of the current. So, if the current is flowing in this direction means the direction of the thumb will be its the direction, means the current if it to be flow in this direction means the magnetic field created that is in its the opposite direction. So, the magnetic field now in this direction. Suppose you will ask me, sir, the current direction is not in this way. Suppose the current direction is in its the different way, means it is in this way. If it is in this way means what will be the current is flowing in this direction, means your the four fingers to be the rotate likewise. If the four fingers will rotate likewise means it will show in your the outward. So, this is your the outward, already it is in the outward, means it is not your the opposing, therefore, the current direction must be likewise. This is its the current direction. So, this current direction in your the clockwise one, this is in your the anti-clockwise one. So, we by this way came to know how the current being your the developed, and during all the processes means if it is the opposites means the net one will always remain same, one becomes your the positive, one becomes your the negative. So, the resultant is always remain same, therefore, the law follows your the conservation of your the energy. So, this conservation of energy is takes the important role in some short questions, it being your the coming that suppose what type of the law to be your the satisfied by putting your the Lenz law. So, next we will go to know about your the motional EMF. So, motional EMF according to your the name, MOTIONAL, motional EMF. So, motional means due to your the motion. So, due to the motion, if some EMF is produced, then that is your the motional EMF. So, we have an inward magnetic field, and this is your the conductor, and this conductor is moving with the speed of your the V, it has your the length of your the L. And this magnetic field, the speed and the length, they must be mutually perpendicular to each other. BL and V are mutually perpendicular. Then what will happen? Due to its the motion, the induced EMF which to be the produced, that E will be the BVL. This E will be the BVL. So, how this E will be the BVL? Let us now have an imaginary rail. This is your the imaginary rail, and due to its the speed in this direction, suppose the same one came to this position. This is its the first position, say your the first position, this is your the second position. Due to your the speed V, it came from 1 to 2, and it cover a distance of your the dx. So, initially this was its the area. When this being the shifted due to the motion, it being shifted, now it's the area being the increased. As we came to know that when there is a change in the area of your the magnetic field, there will be your the magnetic flux, because phi is equals to your the BA cos theta. When A means your the area, initially it has its this area initially. Now it is being shifted to this position, means the area being your the increased. When the area being your the increased, what will happen? There will be the magnetic flux phi. So, if the magnetic flux will be the produced, then there will be the E. So, you know that E is equals to of the minus d phi by the dt, or in magnitude that is equals to the d phi by the dt. So, that is equals to the d by dt of phi. Phi is equals to the BA cos theta. Theta means the angle between your the B and the A. So, we have said that this is your the B and the area, they are your the mutually perpendicular to in your the same direction, means they are individually in the same direction. This theta is equals to the 0. So, this is equals to the BA. So, d by dt of your the BA. So, if d by dt of the BA, B is the constant, because this magnetic field there is no change, only your the dA by your the dt. A means your the area. What is the area you see? It cover your the distance of your the dx, and the length is your the L. So, this is equals to B of d by dt of area is equals to your the dx into your the L. So, dx into your the L, what will be this one? This L is your the constant, comes out, and this is equals to your the dx by your the dt. So, dx by your the dt, that is nothing but your the V, speed. So, this E is equals to your the BLV, E is equals to your the BLV. So, due to the motion, the induced EMF produced, B is equals to your the BVL. So, we came to know that induced EMF E due to your the motional EMF is equals to this, due to the length and your the Faraday's law, that is equals to minus d phi by your the dt, d phi by dt only it's the magnitude, due to your the negative sign it gives you the Lenz's law. So, Lenz's law, Faraday's law, and your the motional EMF, about this we came to know. As per the motional EMF, we came to know by your the one of the method that this E is equals to your the BVL. This is your the motional EMF. So, another method you can also follow, that is your the method 2. Method 2. Similarly, we have a inward field, this is your the inward field, and this is your the conductor, and though this is your the conductor means it must have its the charge. Suppose we will go, there is a positive charge is here. If some positive charge will be there and it to be or the move in this direction, means with the certain speed v it to be or the move. So though this is your the charge body and move in your the magnetic field, it must influenced by your the certain force, and that force which you will have, that is in your the upward direction, and that is your the due to your the magnetic field. So due to your the magnetic field, the Fm means the force to be or the developed, it will be how much? The F is equals to your the QVB sin theta. This is for your the magnetic field. So F is equals to your the QVB sin theta. But what is your the theta? Theta is the angle between your the V and your the B. So here the V and here the B. So V and the B, they are the mutually perpendicular. You see the V is in the direction and the B is in your the inward. This cross will indicate your the inward one. So they are making the angle of your the 90. So this is equals to your the QVB. So Fm is equals to your the QVB. So when the charges to be or the move and it will go, suppose this is your the positive charge, means if your the some positive charges to be or the created here, likewise some negative charges will also the created here. So the positive charges and the negative charges which to be or the created inside your the conductor separated through a distance, then what will happen? There will be a EMF or there will be a some potential difference, means some field to be or the developed. So within this one some field to be or the developed, and that field means your the electric field. The electric field to be developed from your the positive charge towards your the negative charge, and though we have taken here the positive charges means the direction of the electric lines of force with your the electric field direction, if it is the positive means along the same direction and it is your the negative means in its the opposite directions. So though this is the positive and this is the positive, in its the opposite directions the force will be there, and that is equals to your the electrostatic force, and this is your the Fm and that is equals to your the Fe. So next your the Fe which arises means the force due to your the electrostatic. We know that the force due to electrostatic E is equals to F by Q, as we know in your the electrostatic chapter, E is equals to F by Q. Q is what? Q is the charge. Here the charge of your the electron we have taken. So this Q will be your the E. So F is equals to your the E. So this Fe is equals to your the E into your the E. And though this Fm is equals to QVB, this Q is the charge. This charge is nothing but your the EVB. And initially it has your the magnetostatic force. Due to that magnetostatic force it is coming towards its the end. So that magnetostatic force is generally it is greater than of your the electrostatic force. Due to its the motion, the continuous change of your the charges to be your the proceed. So that continuous change of the charges means here the positive charges will gradually increase, here the negative charges will gradually increase, means your Fe will your the gradually increase. Fe will gradually increase means at the same time Fm will your the gradually decrease. So a time will come when Fm will be your the Fe, Fm will be your the Fe, means Fm is your the magnetostatic force, Fe is the electrostatic force. At this case we will say that they are in your the steady state. So when Fm is equals to your the Fe, Fm means your the force is equals to your the EVB, and this Fe is equals to your the Ee. Fe is equals to your the Ee. Now you see E is your the cancel, then capital E is equals to your the VB. E is equals to your the electric field intensity. You know that electric field intensity and your the potential difference. Electric field intensity is negative of your the potential difference, or V is equals to your the ED, you know, means V is equals to ED. E means is equals to your the V by D. So E is equals to your the V by D. You see this is the E. E means your the V. V means your the potential. That is the induced EMF. If we take induced EMF equals to your the E. Here the E is the charge of the electron we have taken. Here it is the induced EMF. So if it is the induced EMF E, so V by your the E. E is equals to your the VD, E is equals to your the V by D. So E is equals to your the V is equals to your the, let us first write here the V, D is equals to your the distance. So what is the distance? If that is equals to your the L, and that is equals to your the VB, and this V is the potential, this V is your the speed. So this potential we have taken as the induced EMF. So EIN is equals to your the by L is equals to your the VB. So EIN is equals to VBL. EIN is equals to your the VBL, means induced EMF is equals to your the VB into L. This is it's the second method, and as we derived in the first method also, E is equals to your the VBL. But if they are not mutually perpendicular, here B, V and L, they are the mutually perpendicular. Suppose they are not in your the mutually perpendicular way. So if they are not in your the mutually perpendicular way, you see the motional EMF due to your the current, that will your the QE. So QE and your the VBQ, they to be your the same. And if they two be the same, then E is equals to the VB. So if we will equalize, you see there will be the two different forces. One force is along your the FM, another one is your the FE. So they to be near the equilibrium position. So after equilibrium, you will find that E is equals to your the VBL. So E is equals to your the VBL. This is the derivation. So if this E is equals to the VBL, but they are not in your the mutually perpendicular to each other. Suppose this is your the V direction, this is the B direction, they are making your the certain angle, this is the length with your the B, it is making your the certain angle alpha. So there is a variation in its the value. So if we take the different angles, then E is equals to your the V vector cross B vector dot of your the L vector. E is equals to your the VB into your the L. But when they are mutually perpendicular to each other, then V and the B, they are mutually perpendicular, means along your the VB sin theta. Here theta will be the 90, so that will be the VB with your the L. Though they are mutually perpendicular, means this VB direction and the L direction along your the same way. Therefore, this is equals to the VBL. So the conclusion is, when VB and L are mutually perpendicular, then E is equals to your the VBL. Second one, when any two are parallel, then E is equals to your the 0. Means out of the VBL, any two with V with the L or B with the L or L with the B, if they are parallel, then E will be your the 0. So this is your the final expression of your the induced EMF in the vector form, in its the magnitude form, that is equals to your the VBL. Okay, thank you very much, students.